Good afternoon, everyone. I am Likita MP, Project Associate to Department for Climate Change, MPRE. I welcome all of you for this webinar being organized on the occasion of World Water Day by the Department of Climate Change and Department of Environmental Information Awareness Capacity Building and Livelihood Program, MPRE, Ministry of Environment, Forest and Climate Change, Government of India. This afternoon, we all have gathered here on this auspicious occasion to celebrate and sensitize the importance of water and to accelerate the change. I welcome all the participants and our Director General Dr. Jagmohan Sharma. Now I request Dr. Jagmohan Sharma to speak a few words on this World Water Day. Over to you, sir.
Thank you very much, Likita. As we understand that the World Water Day is notified by the resolution of the General Assembly of United Nations, when they realized that the availability of water is constrained and it is likely to limit the economic growth and thereby the welfare. Thereon, the stress pertaining to water has only increased. On one hand, the supply has dwindled in the sense that whatever freshwater resources we have on surface, most of them are now polluted and are such which cannot host life. And the example is the number of lakes that we have at Bangalore. There, the water quality has gone down because of the sewage disposal and other industrial waste is being put water bodies. On the occasion of Water Day, today Ms. Sana is going to present to us a very exciting idea where she's trying to club the plastic, which has become a menace. She puts together use of plastic waste, uh, converting that into nanomaterial, and then with the help of biosensitized sensors, she thinks it's possible to make that material sense the E. coli content in water, and this material will be able to remove that impurity. So if that becomes possible, which is her very exciting idea, and she wants to work on this idea, so this webinar in this context is very apt, in the sense that she's trying to assess her own idea on this occasion by sharing it with all of us, so that she gets an opportunity to think deeper about it. And we are all of us would be wanting to assess the practical feasibility of the idea. I welcome her to this webinar, and apart from the members of EMPRI who are there in the seminar hall, I hope that persons from larger civil society would also be gradually joining for this. This is going to be very exciting. I would request all of you to please pay attention to what she's projecting, yeah, so that EMPRI can take up this project on nano material driven from the plastic waste.
Sir, can you hear us? Sir, I think we lost you. I guess he is having some network issues. Unmute. Sir, you're on mute.
I just wanted to say that I'm done with what I had to share with you. Please go ahead with the webinar.
Okay, so thank you for your valuable inputs. Now I think that is a good start. As accelerating change to solve the water and sanitation crisis is the theme of the World Water Day 2023, I would like to start this session with a small story that is the story of a hummingbird. One day in the forest, a fire broke out and all the animals ran for their lives. They stood at the edge of the blaze, looking at the flames in terror and sadness. Up above their heads, a hummingbird was flying back and forth with the fire over and over again. The bigger animals asked the hummingbird what she was doing. The hummingbird replied, I am flying to the lake to get some water to put out the fire. The animals laughed at her and said, you can't put out this fire. So the hummingbird replied, I am doing what I can. So no matter what, the smaller actions you take will help to solve this water crisis. So even you can be the hummingbird. Now I'll introduce our today's speaker, Ms. Sana Skauskar Singhi. She has pursued her BE from Basveshwara College of Engineering, Bagalkot, and she has pursued her MTech in Biotechnology from RD College of Engineering, Bangalore. She has pursued PG Diploma in Food Processing and Nutraceuticals through Biotechnology Skill Enhancement Program. She has worked as Senior Research Fellow at ICAR India Bangalore. Currently, she is working as a Project Associate 2 at M3. Now, I request Sana to give her insights on smart on-site plastic waste derived nanomaterials-based biosensors for water quality. I welcome you, Sana. You can please carry forward the session. Thank you, Likita. Good afternoon, everyone. Please let me know my slides are moving or not. Slides. Just confirm. Just confirm. Am I audible? Am I audible? Okay, I will start. World Water Day is celebrated on March 22 since 1993. So the main focus of this day is to highlight or to aware the public related to the importance of fresh water. As we know, the basic need of every human is food, water, and shelter, right? Without which there is no life, right? Let's join hands in preserving our one of the precious resource in our planet, that is water. This World Water Day, the theme is accelerating changes. Accelerating changes to solve water and sanitation crisis. So, right now, we are off track to meet Sustainable Development Goal, that is SDG 6, clean water and sanitation for all by 2030. According to latest data, that is government must work on an average 4 times faster to meet this goal. But it is difficult that one person or group to achieve this goal. So as we know, water affects everyone, right? So we need everyone to take action. The global campaign, Be the Change, encourages people to take action in their lifestyle. How they use, they consume, and they manage water. These promises from individuals and communities will contribute to the water action agenda. Alongside larger commitments from government, companies, organizations, institutions, and coalitions. We face a water sanitation crisis. Do we stand and share or do we? So I am playing my part. I will choose action. Action in the form of innovative direction to safeguard our precious resource, that is water. Acts. Sustainable Development Goal 6. Clean water for all. Right? Clean water means potable water and free from harmful chemicals, pathogenic microorganisms, and other impurities. By professional, my action is towards pathogenic microorganism present in water. So there are common pathogenic microorganisms present in water are bacteria, viruses, and protozoans. So here my focus is on E. coli. E. coli is one of the strong indicator for contaminated fecal contamination. So, according to WHO, World Trade Organization, at least 2 billion people globally drink water that is contaminated by feces, and over 5 lakh people a year die from related diarrhea issues. So, as per WHO, the E. coli bacterial count should be 0 in 100 ml of water. So, to help society for clean and drinking water, it is important to detect these harmful bacteria. Along with water pollution, another severe environmental issue, that is plastic pollution, right? Global. It is a global environmental issue. So plastic accumulation adversely affects humans, animals, or wildlife and habitat. Why plastic pollution, plastic accumulation happen? Because of increasing the production every year and mismanagement or the lack of waste management. So that is only 9% of the waste, plastic waste is recycled annually. Then what next? So again, we have to search for alternative approach, right? That is recycling. Along with recycling, upcycling technology we need to adopt for sustainable environment. Recycling is the process of transforming your waste into value-added product. In a common sentence, we will give it a new life, new function, right? So here is example is that plastic waste we can upcycle into fuels, chemicals, or nanomaterials. Till now, I discussed about two major environmental issues related to water pollution and plastic pollution. Now, the question is, environmental researcher, can we take action to cope up with these issues? So the answer is we can. Now, I'm coming to the main topic of this World Water Day is the development of smart on-site plastic waste derived material based biosensor for detection of E. coli water. Basically, it is about the development of biosensor and the incorporation of the nanomaterials synthesized from plastic waste. So, what is this biosensor? Biosensor can be a device that produces a measurable signal proportional to the concentration of the target analyte. Usually, it's an incorporation of sensing element, biological sensing element, and measuring signals derived from biological interaction. Here, explain how it is possible. When your analyte present in the sample interact with your sensing element, the sensing element is basically attached to the transducer. What happens? This transducer convert the signal what is generated from these two, convert and amplify it through amplifier and then process it. Then Through that, we can treat it. So this is the biosensor, the core. Biosensor can be constructed using these components, sensing elements, that is also called as bioreceptor or recognition element, because here antibody we can use, nucleic acid or enzyme or antigen, any biological entities. Then next is interface. Interface I will explain in next class. Transducer that can convert your energy into the another form. Amplifier, it will amplify the signal generated from. Processor, it will process and give output that display. So now, nanomaterials. What is this nanomaterials? Nanomaterials are the materials that can manipulate into the nano cells. Nanoscale, 10 raised to minus. So how these nanomaterials play a major role in constructing biocells. So we can call these nanobiocells. It's a class of biocells. Here, the interface in this diagram is nothing but the nanomaterials that can be synthesized from your plastic waste. And to form a functional interface is one of the most challenging work in biosensor design. However, the sensing elements, this is susceptible to their environment. They easily denature, easily inactivate because it's a biomolecule. Biomolecule cannot be attached directly to the transducer. This interface keeps the stability. So to keep their biological sensing activity of this, it is necessary to design a stable interface. Then the stability of this interface decides the performance of your biocells. What is the advantage of immobilization of these nanomaterials on the surface of transducer? That is, it gives specificity, it gives accuracy of detection, then stability, sensitivity, even tiny amount of biomarker in your sample that can detect. And it also gives conductivity to the transducer. Nanomaterials can be the carbon-based nanomaterials. So, plastic waste is rich in carbon. We can produce carbon nanomaterials. That is called carbon-based nanomaterials. So, these are carbon-based nanomaterials. Nowadays, it has a huge application in drug delivery, tissue engineering, of course, biosensors, cancer therapy, etc. And we can produce different types of carbon-based nanomaterials, such as graphene, nanofibers, nanotubes. And based on the sensing element and transducer, this biosensor can be classified. There are different types of biosensor we can get. So, for example, here the sensing element. The sensing element is our biological element. If I'm using enzyme in my biosensor, that is called catalytic biosensor. Yes, if I'm using antibody in my biosensor, that is called immunological biosensor. So same as in case of transducer. Electrochemical biosensor, it means the transducer which you are using, that is convert your chemical into electrical signal or optical, that can see by your eyes, like color changes, piezoelectric. There are many applications of biosensor in drug discovery, environmental monitoring, soil quality monitoring, food quality monitoring, water quality management, even it acts as a prosthetic device. As many biosensors are developed till now, but the more successful biosensor in our day-to-day life, that is glucose biosensor and pregnancy kit monitoring device in market. Why we need to develop biosensor? Because as we know, the conventional method, that is, for example, most probable, so that demands expertise. We want training, time consuming, laboratory form, laborious task, and lack of sensitivity on it. Whereas biosensor provides no expertise, person is required, rapid detection, on-site detection, or we can use easily. Specificity and sensitivity is more, and it is highly accurate, give highly accurate due to these nano materials. So the next is future of nanobiosensor. The future of nanobiosensor is likely to involve the combination of artificial intelligence and big data. That is called intelligent biosensor. That has become a new research topic field. So the main objective of this discussion is to develop smart and innovative technology for detection and monitoring water quality. So the focus of this is to benefit humanity, society, and organizational well-being. The conclusion is that as the development of nano biosensor is challenging, but it requires a more comprehensive and more detailed review about plastic waste derived nano biosensor, for further long-term and in-depth research. So, hope this idea is to provide innovative action and direction for research. I will end this talk by saying, be the change you want to see in the world. Thank you. I guess now it's the time to open the chat box. You can just type your questions there. If you have any. Even offline participants can ask their questions. Any questions? Online participants, please type the questions in the chat box. I guess there are no questions. Okay, thank you, Ms. Sana, for your valuable insights. The talk was very technical and informative. Now, I guess it's time for vote of thanks. So I thank all the participants for participating and making this event successful. Last but not the least, I would like to thank Dr. Jagmohan Sharma for giving me this opportunity and also my colleagues to make this event successful. Thank you, one and all. Have a great day.